Welcome back. And before I start this video, I just wanted to mention that this was previously released, and since then I've made an update to the way the circuit breakers are installed. They're now installed the other way round to what you see in this video. Now that was after checking with the manufacturer just to see which way they should be installed, and I'm just going to put something on screen now just to show you the right way it should be. So this basically means that the battery should be where the input comes in, and then the inverter should be where the output's shown on that diagram. So I've actually corrected that in my current setup, and I've just put a picture up on screen of that as well. So the contents you're about to see haven't changed since the original, but what I will do throughout the video is just put reference points in there to tell you where I've changed the configuration of the circuit breakers. And I just want to thank the viewers that I've had discussions with about this on breakers and using fuses for this setup, and I hope this actually clears up some of what I've been talking about. But again, if you have any further questions, please put them in the comments section below. Anyway, back to the original video. In this video I slot and slide, vent some frustration and make something beep. It's Da Vinci time. To the many of you that have been asking to see DIY on the channel, the wait is finally over. And in this video I do the first build of a 12-volt modular solar charging station. For this, what I'm calling the Mark 1 build, I had a list of requirements. So first up I wanted light touch DIY, so actually putting the system together required as little DIY as I could get away with, and that also includes no building a battery from scratch. So next up I wanted a modular design, so it's quick and easy to break down and then reassemble elsewhere. So next on the list was having a flexible system with the fewest components possible, and ones that were also easy to swap out. Next up was having something that was reasonably priced in comparison with all-in-one systems with a similar spec. So next on the list was having something that was easy to adapt and improve upon, so I could take forward what I'd learnt for future projects. And finally, a system based around an MPP Solar inverter, because they're known in the market and they're an established brand. Anyway, enough chat, let's go. So when you empty the box, this is what you're left with. So front and centre obviously is the main unit itself. Over here we have a CD which contains the watch power software. So this software can be used to configure and also monitor this unit, but you can actually achieve most of that by using the front panel. So over here we have a user manual, so this covers everything from physical installation, configuration of the unit, and also troubleshooting. And over here we have two comms cables here which connect right in the side of this unit, and one has a USB output and the other has an RS232 output. So that's the quick cover off of what's in the box, so let's have a look around it. Let's start off with the front of the unit first. So here's the main control panel here, which consists of a display and some control keys here and also some indicator lights here, but we'll cover those later on in the video. And also the main on-off button here effectively takes the unit from standby mode into on, so that means the AC inverter is on when this is pushed, but again I'll cover that later on in the video. Right, time to look at the business end now. So let's start off here with the AC input. So this is where you connect it up to a mains outlet, so if you want to use utility power you can. I'm not going to use this because I want to use this completely off grid. So next up here we have your AC output. So this is where you get your output from the inverter which is built into this. So this is where you run your mains powered devices from the unit. Right here in the middle we have our main battery inputs here, so clearly marked up as positive and negative. Over here we have the PV, so the solar input. So this is where it goes off to your solar panel or panels. And again, that's marked up as plus and minus. And we have two cooling fans right here. So on this side, we have a really handy label. So I'm just going to put that label up on screen now so it's a bit easier to read. And this gives you all the details and specifics of the inputs and outputs of this unit. And I've just covered my serial number up there for obvious reasons. Here we have a vent for cooling and two comms ports here, which you use the cables that come in the box, as I showed you earlier in this video, to connect up to configure and monitor this unit. So nothing much to talk about on this side of the unit other than a vent for cooling. So if we move on to the top now, so there we have our mounting holes there. So that concludes our quick tour. So before I start the process of mounting this unit to the board underneath, I'm just going to remove this cover plate here so we can get at the terminals underneath. So there are a couple of small screws, there's one this side and one the other side, and I will warn you that these are quite small, these screws. I'll just show you that one that side. So I'm hoping that's visible, but it's quite small, so be careful not to lose those. So I'm just going to flip this around the other side now. And let's undo that one as well. And you just need a crosshead screwdriver and it should be able to fit in there, but like I say, be careful because these are quite small. And then that faceplate lifts off like so. And now, as you can see on screen, we've got all the connection terminals in here so that we can screw the cables in. So there's the solar PV one there, there's the battery one there, and there's the AC output from the inverter to the main sockets. Before we continue, I'm just bringing something up on screen from the manual now about mounting the unit and not to mount it on flammable construction materials. Well, this is actually hardwood plywood of 18mm thick. So as this is the Mark I build, I'm just doing it like this for now, and then I'm either going to coat it in fire retardant paint or actually change the board for something else. So it's just to cover that off before we get going. So here are a few bits that you might need to get this first part done. Always recommend wearing safety goggles, that goes without saying. As long as you have a screwdriver to do this bit, I'm going to use a power screwdriver. Also use a bradawl as well to mark out the holes for the screws to go in, even though they're self-tapping. As in the manual, they say that M4 or M5 screws are the ones that you need to do this particular bit. These are 16mm long, and a word of caution on this, always ensure if you're doing this on the floor that your screws aren't long enough and they're not going to go through the back and actually attach whatever you're doing to the floor. So that's just a point of reference on that and a little warning. Ready to go now, so I've got a centre line here and another line to line up both the holes so that when this is upright, this unit should be square. The reason I've got so much extra board on here is the fact this is the first build and I wanted to make sure that I had enough if I'd messed something up or needed to reconfigure it, and if I did keep this board and use it for future upgrades, I had plenty of room to move things around as well. So I've got bradawl holes in here already, so I'm just going to put these M5 screws in, and these are 16mm, so these are slightly shorter than it is on this board, which is 18mm, so these shouldn't attach this to the floor as I mentioned previously. So I'm just going to get my screwdriver and put it in now. So my power screwdriver hasn't got a bit holder that's long enough, so I'm actually going to use good old elbow grease on this. So let's just get that screwed in. Done. Now that's mounted on the board, the first thing we've got to do is connect up the battery via the terminals here. So I'm just going to plan the layout of where the cables are going to run and where the DC breaker is going to sit, because I'm using a DC breaker with my setup. The other good thing about the manual is it actually recommends battery cable size. So for this particular model, which is the 1kVA, and it's being shown on screen at the moment, we need a cable size of 25mm squared, or that's what's recommended. But for this particular setup, I'm actually going to go up the next level. I'd rather over gauge the cable, and I'm going to go for the 35mm squared cable. So here's the cable in question. I've bought 2 meters worth of black and red cable, and this is 35mm squared, and this is good old copper cable. So this is like welding high flex cable here. So this is the good stuff. It is expensive, but it's definitely worth investing in. And the other way that you can plan this out as well is if before you've got the cable and you've got this set up like this, you can actually use some string as long as you pin that string to account for the fact that this can flex a bit. So you can actually use string to see how much of this stuff you need. I just bought 2 meters of each just to cover off as much as I could with the first build. So if you're not planning on making up your own cables, you can buy them pre-made with the lugs already attached to one end so you can connect to your battery, and the other end is stripped back so that you can actually put them straight in your terminals here, or preferably go through a DC breaker so you only have a small run going to that. But if you're not interested in the DIY element of making your own cables, you can buy them pre-made. So in the manual it recommends to have some kind of separate DC overcurrent protector or disconnect device between the battery and the inverter. In my case, I'm actually going to use this DC circuit breaker. This is a 250 volt version and good for 125 amps. So the reason I've picked this particular one is the fact that this can handle almost 100 amps at 12 volts. So what you normally do is apply a rule of thumb of 1.25. So that gives you fuse ratings or circuit breaker ratings. So that's why I've chosen the 125 amp version. For this Mark 1 build, I'm just going to use this little enclosure here to put the circuit breaker in, because again, I prefer these circuit breakers over the others that are available on the market. And then what I'm going to do is I'm going to run the positive wire through this, through the circuit breaker and then to the battery terminal. And then I'm also just going to run the negative wire straight to the other battery terminal. So I've removed the knockout sections on both ends of this enclosure. So ready to go now and start to get the cable cut and put in here and then mount it on the board. So the manual recommends cutting back the insulation by about 18mm to expose the copper wire underneath, and that's to go into the inverter here. But I'm going to do the same at the other end of the cable to go into the DC circuit breaker here into this connection. I've got my large gauge wire cutter here which I'm going to use, and I'm also just going to use a tape measure just to make sure that I get the right amount on the cable. So I've gone around it with this, so let's just pull the insulation off now. There we go. Remember not to cut too far in there, otherwise you're going to lose some strands. There we have, beautiful copper cable ready to go into one end, and then we're just going to do the other one now. Right, so I've just pushed the cable straight into the inverter now, so we just need to get an idea of the length we need to go into here. So we don't put this down first, we run the cable first to know where to mount this on the board. So I'm just going to make sure that's in square. As you can see, there's no exposed copper there, which is great, so that's a really good fit. So I'm going to move that down there to give us enough space in here. Now this is mounted inside the enclosure to see how much we need, including the 18mm. So I'm going to run it like that so I can mount it on the board as well. I can put a cable clip around there. So what I'm going to do now is I'm going to cut it. I'm just going to mark it with a screwdriver around about there. So what I'm going to do now is I'm just going to cut this cable, strip it back so that we can then mount this to the board. So remember, you can use the smaller gauge wire, which is 25mm squared. I'm using the 35mm squared, obviously for upgradability in the future. So let's get that in there. Let's get that into the circuit breaker. And then I'll put it in its enclosure shortly. Just want to make sure it's in tight. That's it, that's in tight now. So let's get that in the enclosure now, so we've got some idea whereabouts this is likely to go. So this just snaps in. There's got a little snap thing here which you can pop out to snap onto the rail. So let's get that in there and snap that in place. So let's just make sure that's nice and straight. And obviously just check the lid goes on as well. And again, you don't need to use this gauge of wire on this, and this is just the Mark 1 build after all. So you'll learn by that. So that looks pretty good there. So we've got a bit of a bow in the cable, which is good, which means I can attach something there if I need to, but it's quite rigid to be fair. Okay. So I think we have a good spot, so I'm just going to level this up and screw it in. So I've got a couple of M4 16mm self-tapping screws here, so I've got the holes marked now inside the enclosure. So let's get this screwed in now, and hopefully let's get that in there like that. That's one. Let's see if I've got the other hole marked correctly. So that's now clipped in there nicely, so we can get the lid on just to check that still fits okay. I won't connect it up or seal it yet because we still need to run the other cable, but there you go, there's the first connection made. Now that we've moved into kind of portrait mode to continue the build, I just wanted to cover off this stand that I've made for the board to slide into. So the reason I've done this is so that it's more of a modular design, so this solar station can be broken down, moved around and reassembled somewhere else. And the other plus point for this is the fact that it has two sides to it now, meaning you can store your batteries here and store your batteries here, but also I can use the back side of this board here to actually construct my 24-volt system. So it's actually got dual purpose, and I can use that and get more out of it than just building from one side. So it really is just slide and go when it comes to reassembling. So once the build's complete, you just put your batteries in there, connect all your connections up, and away you go. So I've got the rest of the positive cable here which will connect to the breaker here, so I've stripped back 15mm on here so that fits perfectly in there. Then I just need to prepare this end here so that we can actually get the lug on there to connect it up to the battery terminal. So what I'm going to do now is I'm going to just prepare the other cable, the negative cable as well. and then try and compare the sizes, because that's going to bypass the breaker and go straight to the battery. So I want to get them fairly equal length so it actually connects up fine. But I'm just going to show you about these particular lugs and how to size them up correctly. So when it comes to choosing the right size lug for your setup, there's two things you need to consider. So first up and most obvious is the cable size or the gauge you're going to use. So in this case we're using 35mm squared, and that really comes into its own when you actually put it in the lug and you see how good the fit is, ready for crimping. But the second thing you need to consider is the size of the hole. So this relates to the terminal you're going to connect it to. So in this case this is an 8mm terminal, and you can actually measure that, and I suggest doing that with something that's plastic just to check what size hole would be best. So you've got your two key indicators on there and the size of lug you want. So as you can see, the negative cable's been stripped back now 18mm, so I'm going to get this in here so we can get the cables the same length. So the cables are now held in place around the circuit breaker, and lucky for me I didn't actually need to cut the negative cable because they both come out at the same size. So now they're both stripped back. All I've got to do is put the lugs on and then connect it to the battery. So I'm using a hammer crimp, so you effectively hit it on here and it gives a good crimp on the cable. So you can get the hydraulic ones as well. I'm going to get one of those at a later date, but this is the one I'm going to use to crimp these cables. Right, favourite bit now, so you've just got to make sure it's lined up properly and then just hit it. Until the noise changes. Lift it up. And look at that. Oh, I hope you can see that. Perfect crimp. So as you can see, two perfect crimps. I'm just going to slide up the heat shrink, get my heat gun and finish this off. Right, time to connect up my battery now. And before I do, there's just a couple of things I need to check first. So first up, on the unit itself, I just need to make sure the inverter is switched off. So that means this button is actually out. So if it's in, that means it's on. But I've just checked that now, so that is now out. And the second thing as well is if you're using a circuit breaker like I'm using, just make sure it's in the off position, or at the moment it's showing green, meaning that it's actually switched off. And it will turn to red when I switch it on in a minute. So let's get on and connect up the terminals. So connected up now, so I'm just going to switch on the circuit breaker, so switch it to the up position, and as you can see it's on now and it's got red there, meaning that the circuit is now live, and I'm going to switch on the inverter and see what happens. Sorry about that noise. And there we have it, we have an output there of 229 volts. So we can flip through using the second button on here. I'm hoping that's visible. Just have a quick flick through. So there's nothing else coming in because we haven't got any of the other inputs set up as it stands at the moment. But it gives you a battery voltage there. And also the fact that it's actually 50 Hertz. And currently there's 0 load. And there's 1 amp. So that's actually standby consumption. So that's what the inverter uses from the battery when it's actually pulling no loads or providing no loads on the AC outputs. So as part of this first build, I bought myself a standard mains extension cable, and as you can see this is a two-way one here. And then I took the plug off the other end, so I had the 3 wires to connect to the AC output terminals right here. So what I will say is before you do any work on this, make sure that you read the manual. So I'm just going to put that up on screen now so that you have a good read of it, but you must read the manual. Right, before I can connect these wires into this terminal here, I need to stop. So this is really important. So I need to make sure that everything is switched off, powered down and isolated. So the battery is isolated and the inverter is off. So first off, I'm going to switch off the inverter. Let's wait for that to power down. Okay, so I'm now going to switch off the circuit breaker. And as you can see, it's turned back to green, meaning that that is now isolated, meaning the battery is isolated. And now that means I can go ahead and connect these up to the terminal. Before I secure this cable down like I've done with the others, I'm just going to do a quick test to see that this works and actually powers an AC load. So I'm just going to switch the circuit breaker back on now. So it's displaying red again, meaning that the circuit is now live. So let's switch on the AC inverter. And there should be a light that comes on there if it's working as well. And it's on. So let's see if you can see that on camera. I'm hoping that's in focus. So I'm just going to grab one of my filming lights now and plug it in. As you can see, the filming light is off. Here is the plug. So let's just plug it in to the extension cable. And there we have it. So that's just a quick test to check that it's powering AC loads. So in order to secure this cable that I've just added to ensure there's no tension and it doesn't pull out from the terminals, I've just picked up the AC input cable. So this is what you use to hook up to your mains outlet if you want to use utility power. I'm actually going to show you a different cable which has a standard 3-pin plug on this later on in the video. But so what I'm going to do is I'm just going to plug this in now to check that it doesn't actually interfere with it. So that's plugged into the AC input now. So that enables me to go ahead and then just put this on here on the backboard and secure it properly. Right, for this build I just wanted somewhere to hang this when I wasn't using it, so I'm just going to use a larger cable clip here and secure it just by the back here so it acts as a hook to keep these sockets out of the way when they're not in use. Done. Right, it's time to hook up solar now via this terminal right here. And to do that, I'm going to be making up my own cables and also connecting up using a DC breaker. So I've got another DC breaker here, which is smaller than this one we use for the battery. So this one here is rated up to 125 volts DC, and it must be a DC breaker, I must emphasize that. And also rated for 50 amps. So I'm going to be using some of this cable for my setup, and this is actually solar cable. And this is 6mm squared and rated up to 1.5 kilovolts. So this is way over what I need for my 400 watt panel array to connect up to this unit. But I'm just bringing up something out of the manual now, which does actually have a recommended wire size of 10mm squared. But for my particular setup, this should be more than adequate. So I'm going to use another one of these enclosures for the solar DC breaker, just like I did for the battery one here. So I'm now going to map out using the wire how much I need and where I can install this on the backboard. Right, so it's time to rinse and repeat what I did for the battery circuit breaker, as in run a small amount of cable out from the positive terminal into the circuit breaker and then out the other side, and then also run a negative cable round, and they'll both end in MC4 connectors ready to connect up to my solar panels. So I've just put something up on screen from the manual which shows I need to remove about 10mm of insulation before I insert this into the terminal, and once I've got the right cable length for the circuit breaker, which is this, I then need to remove 15mm of the other end to go straight into the top of this. So something I do when I'm using cables of the same colour is I just add something to indicate what's positive. And in this case I'm using a bit of red electrical tape so that I don't get confused when I'm wiring things up. So usually when you connect up to solar panels, this MC4 connector from the panel is positive and this one from the panel is negative. So what we need to do to connect up to this breaker here is we need to turn them around. So this one now becomes the positive and this now becomes the negative, which we connect up to the other terminal up here. But of course, before you connect any of this up and you actually connect solar panels directly to it, we're going to check out using the multimeter to make sure the polarity is the right way round. Always recommend that just in case you've got them wired the wrong way round. Right, time to hook up to this 400 watt panel array now. So I've moved out into my garage now, ready to connect up the solar panels you've just seen. So here are the connectors from the solar panel. So we just need to ensure the polarity of these are the right way round, so that we're plugging in the positive to this one here and we're plugging in the negative to this one here. So I'm just going to grab my multimeter now so that we can check these before we plug them in. So the multimeter's hooked up now, so we just need to ensure that this connector here is the positive, because that then needs to feed into and connect to the red mark one on here, which is the positive for our solar input. And on the reading there is no actual minus sign, which means the fact that this is actually reading true. So red is positive and black is negative. If you did get them round the wrong way, it would come up with a negative figure. So I'm just going to swap them round quickly just to show you. So now on the screen it's saying minus 43.1, meaning these are actually crossed round the other way. So I've just moved it back again just to ensure that we've got it round the right way, ready for plugging in. And there we have it. So we've got a reading without any minus figure, meaning that that is the positive and that is the negative. So we can hook it up. Time to hook up the cables now. We've checked the polarity. So I'm just going to make sure that the breaker is switched to the off position, which it is at the moment. It's pointing downwards. So it's time to put the cables in. So positive to positive and negative to negative. Solar switch on time now, but before I do that I just need to make sure the battery is connected. So I'm going to flick up this circuit breaker here. So that means that circuit's now live because it's showing red on there, meaning the battery is connected to the unit. And now I've done that, I can actually switch on the solar power input. So let's give that a few seconds and then hopefully the screen will wake up and show us what it's bringing in. And there we have it, we've got a solar panel there and the battery there. And look at that. It's now charging the battery directly. And we have a little charge light flashing there as well. So I'm just going to flick through here to show you the details on the solar panels. So there we have the input voltage at the moment. So it's about 33, and you can probably just hear the fans cutting in now because that cools the charger down inside. So we've got about 33 volts at the moment. So if you click it again, that's currently bringing in about 24 amps through the charger. And then hopefully we push it again and look, we're bringing in 320, about in the 320s in watts terms from the panels you've just seen. So that is brilliant. So at the moment, that is, you don't need to have this switched on either because this is to switch on the inverter. So at the moment you can still run this without the inverter being powered on. So if we power that on now, that means this plug socket here will become live. And as you can see, when you switch the inverter on, it readjusts itself. So we've now got the battery going to load and it's just waiting to reconnect up for the solar. And there we have it now. So it's reconnected, so it's actually bypassing straight through to the load, and it's also charging the battery at the moment from what's coming in from solar. And there we have it, so it's bringing in around the 300 watt mark now. It's also powering the loads here, so it's powering it straight to here, and it's also charging the battery. So solar power connected. So if you want to use utility power with this unit, you can do, and this cable comes in the box. So this end here plugs into a wall outlet and this end here plugs straight into the unit. But if you're in the UK as I am, you need one of these plugs which has a 3-pin one end and the same connector the other end to go into the unit. So the reason I didn't tack this on the back of the board here is the fact that it's really handy having one of these you can actually put in and remove. So it helps with this whole modular design, so I can break this down, get all the cables in one area and then transport it to somewhere else. But on the other models you actually have to wire it in directly for the AC input right under here. But this one doesn't, because you can plug this in and remove it at your leisure. So connecting this unit to utility power really is as easy as plugging the connector into the bottom of the unit here and then taking your 3-pin plug if you're in the UK and plug it into an outlet of some description. But before you do that, just make sure your battery is switched into the on position. So I'm going to do that now. So we're plugged into the mains. Just give it a few seconds to see if it wakes up. And there we have it. So it's telling us the AC input there, so that's 249 volts at the moment. And again, you can always scroll through using this up and down arrow button right here. So it's telling us it's 50 hertz there, and we've got the little symbol there indicating we've got mains power. There's nothing connected to the battery yet, even though this has got an internal AC battery charger. So let's click on it again. Okay, so we haven't got PV on at the moment because I switched the PV off. So let's cycle through. So again, you just keep pushing the same button here, which is the up and down one. And you've heard the fans kicking in there. Let's go back up now. So it's still showing us the mains voltage at this socket here. And it's at 50 hertz still. And again, there's no PV, but as you can see on here now, it's actually charging the battery directly from mains. And now it's connected up to the mains, you can actually just switch the inverter on here. So I'm just going to switch that on now and we'll see how the display changes. And you heard a little click there because that's actually the automatic transfer switch, which effectively uses that from the mains and switches the mains into what's called bypass mode straight to the load. But now it's actually reconnected to the battery. So the mains supply at the moment is charging the battery and it's also going straight out to the load, which again at the moment we haven't got anything even though the inverter's switched on. So that's connecting utility power. So now I've got mains power actually charging the battery and bypassing to the inverter here. So you can see the inverter is on because we've got a light on there, and also it's saying there that it's charging, so it's also charging the battery. So what I'm going to do now is I'm going to switch solar power back on now and see what happens. So as you can see, we've got a little solar panel that's now appeared under the main symbol. And I've currently flicked this switch here so that we've got the PV watts coming in. So as you can see, the PV, as in the solar watts that are coming in, are now going up, they're now rising. And you can actually see there where it's actually changed its charging profile, and that can be set up within the unit itself or actually using the software or using this front panel here. And I've got the priority charging for the battery coming from solar, and as you can see the solar panel here is going in and it's actually charging the battery directly, but the mains has now bypassed that and actually going straight to the load. So solar is now providing about 200 odd watts, and the inverter is switched on as well. And again, you don't always need to have the inverter switched on, you can leave the inverter switched off. So I'm going to switch that off now, and that will now switch off the AC. So the AC is no longer powering the load, and we've just got the solar panels charging the battery directly. So the case battery is fine for running AC loads via the MPP inverter and also being charged by solar or utility power. But what about charging or running 12 volt devices? Well, in an effort to try and cut down again on the DIY elements of this particular build and remain modular, what you can actually do is you can actually run directly off of the battery itself to charge and run your 12 volt devices. So as shown in the case battery review video I've just suggested, I'm just going to attach a couple of these cables as I do there to give us 12 volt cigarette lighter outputs. But before I do that, I just need to isolate the battery from the unit. So I'm going to switch off the circuit breaker. So now I'm going to attach the cables. And there we have it. two live 12-volt cigarette lighter outputs. As you can see, the charging station setup for this build is now complete, and again, no additional DIY was required for this element, so connecting straight to the battery, which would be charged by utility or solar power under normal circumstances. And then we've got the two 12-volt outputs over here, which are connected to the two chargers so that we can charge the EB150 here and the Jackery Explorer 240. So let's start off with the Jackery and just plug that one in there and see what we get. So okay, that's woken up and that's charging at 64 watts. So let's plug in the big beast, the EB150. And you can hear the fans come on, and now that's charging at about 113 watts. So again, this setup here you can pretty much use with this and also run off of solar at the same time. So one of my key requirements for this Mark 1 build was to be a modular design that was quick and easy to break down and reassemble somewhere else. So in doing that, it's actually turned out better than I thought, because in actual fact, disconnecting the battery, taking the backboard out and putting it in the boot of my car takes very little time at all. And again, if you don't want to use the stand, you can still mount this particular backboard or strap this backboard to something else while you're out and about. As long as it remains upright, you'll be okay. And it is so quick and easy to break down that I'm going to do it right now. I'm just putting up a picture of it in the boot of my car now. Time for a quick look now at how to change the settings on this unit using the front panel, and you will need to refer to the manual because everyone will probably have different setups and the way they want to use their device. But I'm just going to show you how to change one of the settings now on here, just so that you've got an idea. And coming up after this, there will be a quick tour of the software and just showing my current settings that I'm doing. But I just suggest you change one thing at a time though, like the battery type and then maybe your output preferences, before you start tweaking too many things at once. So that's just my advice for you off the bat. So to get into the menu system, you just push and hold the bottom button for a few seconds. And again, you will need the manual for this to get the setup right. So it starts at 00 on the menu, and just the up and down arrow key here takes you through each of the options. So I'll just go into an option in a minute and I'll just show you. So on this option here, for example, if we wanted to edit that, just press the button again, as in the enter button, it takes you in, and now it gives you the option to change this. So again, you go back to the up and down arrow key and you can flick through as a UPS or appliance option. I'm leaving it on the appliance option. And then when you've got the option you want, you just press the enter button again. Okay, and then you can continue scrolling through the rest of the menu until you get to the option that you want to change. And to escape the menu, just press the top button here and it takes you straight back out to the standard menu. So that's how you change individual settings, but again, you're going to need to look at the manual to see how you need to set it up for yourself. So before I go ahead and just do a quick test of the 1000 watt inverter, I'm just going to swap over my case battery to the newer case battery now, because this actually has more charging for doing this particular test. But again, this is the beauty of these. You can swap these out and still run the system fine, even if one's got a higher state of charge than the other. Swapped out now, switched on, time for a cuppa. Right, time for a quick inverter test now. So I'm just going to show you what happens when you go over the 1000 watt limit when you haven't got utility power connected, because obviously when you've got utility power connected to the MPP, it bypasses the inverter and goes straight out to deliver the load. So I've got two kettles here. I've got an 830 watt here and a 500 watt here. This 830 watt uses about 750 when it's on, and the 500 uses about 450 or 460 watts. So let's see what happens when you try and go over that limit. So let's flick it on. So the fan's come on now. It's already flashing up saying that there's a problem and the load is too much. And there we have it. The inverter has actually cut out and the fault light is now on. And then I'll need to reset the inverter by switching it off and on. And switch it back on again. And there we have it, it's just coming back on now. So it's reset and ready to go. So let's test off with the 500 watt kettle. So unfortunately the camera died, so I'm actually going to use the 830 watt kettle now to see what it pulls up on the MPP. So let's kick off now. Okay, it's now saying it's using about 753 watts. And the fans have now kicked in, as you can hear on the MPP. Yep, so it's stable around 750 odd watts. Time for a cuppa. We hoped you liked our video. All the links you'll need will be in the description below. Please like, share, subscribe and hit the bell icon. And stay tuned to Dad Vinci.